Students, now I am going to explain the MCQs from the P block elements which can be covered in the previous year exams and followed by can able to cover some tips I am going to give in this case. Let's see. See, the first question is the correct order of atomic radii. The correct order of atomic radii in group 13 elements is boron, aluminum, gallium, indium, thallium. In that case, boron is less than gallium, is less than aluminum, is less than indium, less than thallium. Why means d orbital have less shielding effect, so s orbital have more penetrating power. In case of gallium, the d orbital is coming to enter the electrons. Okay, so here shielding effect of the d orbital is less, then s orbital strongly attract towards the nucleus. That is which electron? A 4p1 electron strongly attract towards the nucleus by opposing the d orbital shielding effect. Now next question is, see now, which of the following is unstable to form Mf63 minus ion? In this case, the options are given as gallium, aluminum, indium and boron. Here the boron is 1s2, 2s2, 2p1 and here 1s2, 2s2, 2s1, 2p2, it is in excited state. In this case, the boron can form only Bf4 minus. Why means the electrons only enter into the p orbital. Maximum it can form the 4 bonds with the 4 fluorines. There is no chance to get the Mf63 minus. Next question is, name the gas that can readily decolorize acidified KMnO4 solution. That is CO2, SO2, NO2, P2O5. In this case, SO2 gains oxygen then changes to SO3. So that can be gained from the acidified KMnO4 solution. That equation is that KMnO4 plus H2SO4 gives rise to K2SO4, MnSO4, H2O. That can be gained by what here? SO2 then changes to SO3. So SO2 is further what here oxidation can take place. Why means sulfur maximum oxidation state is plus 6. Now SO2 form this oxidation state is plus 4. So this is the good what here the gas can decolorize. But CO2 maximum oxidation state plus 4. NO2 maximum plus 3 then plus 4. Okay, then P2O5 plus 5. Already the oxidation states are satisfied. Now the in which pair of ions both the species contain SS bond? So first see the structure. B option case, the structural based question this is. So B option structures we have drawn, SS bonds are existing. Next is the what is given here. It is because inability of ns2 electrons of the valency shell to participate valency shell to participate in bonding, that Sn plus 2 is reducing agent while Pb plus 2 is oxidizing agent. Okay, remaining 3 options is there. Here how can you explain? It is because of the inability of ns2 electrons of valence shell to participate bonding that case here Sn plus 2 can lose the electrons. Okay, okay, and Pb plus 2 cannot lose the electrons. Why means Pb plus 2 is the stable oxidation state. Now you have seen that case ns2 showing inert pair effect in case of what? ns2 electrons is showing inert pair effect. That is what inert pair effect will be increases in case of P plus 2 ion is more stable than Pb plus 4, but Sn plus 4 is more stable than Sn plus 2. Why means in this case no inert pair effect. Okay, so that's why Sn plus 2 is what here reducing agent while Pb plus 2 is oxidizing agent, right? Now next question is what here match the interhalogen compounds of the column 1 to column 2 assign the correct code. Column 1 is given xx dash xx dash 3 xx dash 5 xx dash 7 and the shapes interhalogen compounds these are. Okay, so T shape and pentahalogen pyramidal and pentagonal bipyramidal, linear square pyramidal, tetrahedral. What is there? Now, in case of the halogens X electronic configuration, you know ns2 np5 n minus 1 d0. Hello. Hello. Yes, ma'am. Good afternoon. I'm calling from Vodafone. Yes, ma'am. It's regarding Vodafone plan, sir. At present, whatever you are using plan from the corporate team, they are using this plan. They are closing the plan, ma'am. They are closing this plan. Only I want now 1 month. Only I want only calls, madam. Hello. Okay, okay, madam. 1 month. I want only calls plan. I don't want a net plan. Only calls. Okay, okay, madam. But no. Okay, but I want only. Why means I have taken some other internet, madam, broadband, so I don't want the. I don't want the internet plan, madam. No. I want only calls, only incoming messages. Without data, I can't get calls. I can't get one. Okay, madam. Previous is 299 plan, mine is. And then now. 399, but I am getting 414 amount. Why I got 414 amount, I don't know. 399, 299 plan I have taken, but I got the amount 414. Why I got that amount, I don't know. Okay, madam, I don't want this. 399 I don't want. Any less plan I want. Any other plans is there? Otherwise, 249. That is 1 month, 249. Okay. Okay, madam. Now less than this 390. Now it is not possible to spend more amount. Huh? Okay, okay, madam. Now can't able to spend more amounts. So I want to take the less amount plan. Actual plans are what now? Vodafone postpaid. 3 days plan, is there any plan? See here in this case, the concept is x dash and x dash 3 and x dash 5 and x dash 7 is given. The x dash t shape, okay, have the which electronic configuration, but the structure means there is no chance it will have the linear structure. But x dash 3, this is CCl3 type of, okay, it have the how many lone pairs according to configuration? It will have the three bond pairs, one lone pair. Okay, 3 bond pairs and 1 lone pair. So this will have sorry, that's 2 and P6. It will have the 2 lone pairs and 3 bond pairs, CLF3, 2 lone pairs and 3 bond pairs. So it will have which shape now? T shape, right? Next is x dash 5. It is the BRF5 type. Okay, BRF5, but one lone pair will be there according to bonds. It will have one lone pair, 3 bond pairs, 5 bond pairs. So it actually it is the what? It will have the triangular bipyramidal structure, but due to the cause of what here? Due to the cause of lone pair existing, okay, that will be destroyed, then square pyramidal structure it will exist. Then next is x dash 7, means that is similar to what here? IF7. This is similar to what here now? Okay, IF7. This case, that is the pentagonal bipyramidal structure. Okay, this will have the pentagonal bipyramidal structure. Now matchings you have taken, you got idea. A matches to 3, B matches to 1, C matches to 4, D matches to what here? 2 again. Now see next question. What here? AlF3. Okay, AlF3 is soluble in HF only in presence of Kf. It is due to the formation of what? Okay, it is due to the formation of the compound, ionic compound AlF3 plus Kf, K3AlF6, the ionic compound 3K plus AlF6 minus 3. Next one, when copper is heated with concentration O3, it produces what? Copper react with concentration O3. There is 3 cases you can keep in idea. It is one, dilute, moderate, concentrated. These 3 equations you should remember. Any one of the case you can get the other question. Open cheyadi. A door open cheyadi. Okay. A door open cheyadi. Now the reaction you can guess, it is NO2 gas. Okay. Now next question is, which is the correct statement for the given acids? So the 4 statements are given in this case. Direct we can approach. What is that? Phosphoric acid is diprotic acid while phosphonic acid is monoprotic acid. Okay, phosphoric acid is diprotic acid. Phosphonic acid means phosphorus acid. That is a diprotic acid, you know that. But okay, while phosphonic acid is monoprotic acid, so this is the monoprotic acid. Now that statement is right according to. Now next question is, among the following the correct order of acidity is. Any case, same element oxides is similar, then which have the highest oxidation state. Okay, highest oxidation state that can be have the more acidic nature. So you can get idea now. Okay, now see the given is what? HClO4 and HClO2, HClO, HClO3. Anyhow, the answer is okay. Here in these four acids, HClO4 Cl oxidation state is +7, HClO3 Cl oxidation state is +5, HClO2 Cl oxidation state is +3, HOCl Cl oxidation state is +1. So the order you got idea, I think. HClO4 greater than, HClO3 greater than, HClO2 greater than HOCl. Next is okay. Next 11th question. See the 11th question now. What is the question 11? The product obtained as a result of the reaction nitrogen with CaC2. Okay, then what is the product now? Cn2 plus CaC2 gives rise to CaCN2C. Then that simply you can write what? CaCN twice. Actually that is nitrolim. Okay. Next question is here. Which one of the following orders is the correct for the bond dissociation enthalpy of halogen molecules? Okay, is given the four molecules. What here? F2, Cl2, Br2 and I2 have the inner electronic repulsion in case of F2. So what happened? The bond dissociation energy, otherwise FF bond will be the weak bond in this case. So the bond dissociation energy of F2 will be less than observed Cl2 Br2. Actually theoretically what? F bond is the small bond, so F is the small atom. Then what here? F is the small atom. In that case, okay, F is the small atom. In that case, strong bond should be exist. But here what is happening? Strong bond, not weak bond is existing. Why means? Due to the cause of, okay, due to the cause of what here? Due to the cause of the small size of the what? Fluorine, inner electronic repulsions will come, then bond will be the weak, and next is what? Bond will be the weak and the bond, okay, then you can get the less energy to break the bond of the FF. Okay, now the final okay, you can get the idea. The bond energy is less for F2 than Cl2 and Br2, but I2. Okay, you got idea, right? Now next question is going to explain here similar as before. What the question means? Match the compounds column 1 hybridization shape with the column 2. Now in this case, one is XeF6, XeO3, XeOF4, XeF4. So in these cases needs to see the structures. Okay, now see XeF6 have this type of structure. In this case one lone pair is there, so this is actually what? Square bipyramidal, but lone pair is there, so it is a distorted octahedral. Square bipyramidal, other name we can call as what here? Octahedral, but here lone pair, so distorted octahedral. Next is what? XeO3. XeO3 according to O, so 6 bonds required, 6 unpaired electrons, then one lone pair. Okay, so it is pyramidal structure. XeOF4. XeOF4, okay, NH2 NP3 N-1 D3. O can show 2 bonds and F can show how many bonds? 4 bonds, 4 Fs. So totally how many unpaired electrons required here? 6 unpaired electrons required. So okay, 6 bonds followed by the oxygen can show 2 bonds. One is the pi bond, another one is sigma bond. 4 fluorines can form the 4 bonds and one lone pair. So now it will have what here? The shape square pyramidal structure. Next is XCF4. In this case, the 4 unpaired electrons required. Y means 4 fluorines required 4 bonds. Then how many lone pairs left here? 2 lone pairs left. So it will have the square, okay, planar structure. So finally what is decided? In this case, XCF6 distorted octahedral, XCO3 what pyramidal structure, XCOF4 what square pyramidal structure, XCF4 square planar structure. Right. Now he is going to discuss the stability of +1 oxidation state. What here? The stability of +1 oxidation state among Al, gallium, indium, thallium increases in the sequence. In this case, Al less than, Ga less than, In less than Tl. Already once I gave here, if the +1 oxidation state of thallium you have taken due to the cause of inert pair effect, that is NH2 electrons can't able to remove in this case. But remaining cases, okay, that okay thing will be what happened, decreases. So in this case, Al can shows the +3 oxidation state, okay, and Ga +3, then indium +3, but thallium +3 is less. But +1 oxidation state you have seen, +3 oxidation state stability decreases. That way anywhere asked the question. But +1 oxidation stability increases. I give now only what here, due to the cause of inert pair effect. After removal of one electron from the NP, NH2 electrons can't able to remove. That is, one is penetrating power is more, another one is inert pair effect, and shielding effect is less. D orbital is there 3d10, that 10 electrons and F also there, they will not shows the any shielding effect. So NH2 electrons strongly attract towards nucleus. You can take similar, you can take for the bismuth, next any group of that means nitrogen, phosphorus, arsenic, and one the bismuth. This case Bi +3 stability increases, but Bi +5 stability will be decreases. Next is the question is given as 15. Okay, the variation of the boiling point of hydrogen halides is in the order of what? HF, HI, HB, or HCl. Actually, what depends on this? Actually, molecular weight is more, boiling point is more. But here, due to hydrogen bond in between the HF and HF, what is happening? Boiling point of HF will be more than the HI also. That is observable, and theoretical reasons you are giving. Some cases you are going, you can see the NH3, okay, that cases NH3, next pH3, that cases it will not come as the NH3. In that case, NH3 will be less boiling point, then BiH3 also will come. That is both what here, you can take the theoretical followed by reasoning, okay. But practically, okay, theoretically if you are taken, HI should have the more boiling point, but why? That is reason giving HF have the more strong bond, that is what here hydrogen bond, so that's why it will have the more melting and boiling points than remaining all. Next is due to the cause of the strong hydrogen bond between fluorine, okay, HF. Next question C. Which of these statements given below is incorrect? That is, ONF is isoelectronic with O2N-. That is right. Okay, you can check that. OF2 is oxide of fluorine. That is not oxide of fluorine, it is fluoride of oxygen. Cl2O7 is hydride of perchloric acid. What? Okay. Cl2O7 is an perchloric acid. Okay, anhydride, that is anhydride of perchloric acid. This is, that is also right here. Next is O3 molecule is bent shape. Okay, O3 molecule is what shape here? Bent shape. That is also right here. This is anhydride. Okay, right. Next is 17th question. C. Strong reducing behavior of H3PO2 is due to. Reducing behavior is depends on what? Number of pH bonds. That is based on the, okay, oxy acids. Otherwise that H minus can release, that is the reducible hydrogen. Now in this case, P double bond OH, H and H. One of the POH bond and two pH bonds is there. So this is the strong reducible. Okay, it have two pH bonds, so that's why it can be acts as strong what here reducing agent. Next is what here given. Next is given acidity of the diprotic acid in aqueous solutions in order to see the given is what H2S, H2SC, H2TE. Okay, now in this case bond dissociation energy is less and then that is strong acid. Okay, bond dissociation energy is less, that is what here strong acid. Now you have observed in this case the H2S, H2SE, H2TE, H2TE, the bond dissociation energy is what here very less. So H2TE will have the more acidic character. Next is which of the following structure is similar to which of the following structure is similar to okay, which of the following structure is similar to what about this? Which of the following structure is similar to graphite? So if we have taken the structures, that is BN structure, BN structure have the similar to what here graphite, that is what graphite structure, this is the layers type of structure graphite, and BN will have this similar, so this is the similar to the graphite structure BN. Then which of the following is not an monomer for high molecular mass silicon polymers? Okay, see which of the following is not a monomer for high molecular mass silicon polymer? So in this case what is the answer relates to this means high molecular means Me2SiCl. Okay, Me2SiCl2, this is not a high molecular mass having monomers combined, it is combined by low molecular mass having monomers combined. Remaining all are formed by the combination of high molecular mass monomer combined. Okay, right. Now come to the next question. Here question is given as which of these is the least likely to be act as Lewis base? Lewis base. Very important question. This is F minus BF3 PF3 CO. So in this case, which can be acts as the Lewis base. Lewis base means which can accept the lone pair, but it can be act as Lewis acid. Okay, remaining are donating lone pairs, so they are the Lewis bases, but there is no lone pair to donate from the boron central atom, so it can't be act as Lewis base. It can be act as Lewis acid. So answer is BF3 here. Next is the basic structural unit of the silicates is, okay, that is based on the factor. So answer is SiO4 minus 4. Next is which of the following, okay, which of the following is the electron deficient? So see B2H6, you know that well known, it have the bridge bond. Okay, well known. Okay, that is what here electron deficient. Next is which is the strongest acid in the following? You know that which have the more oxidation state or the more electronegativity, that is also which is the central atom having high electronegative element followed by HClO3 HClO4 in this highest oxidation state. So that case HClO4 have the highest oxidation state followed by Cl is the more electronegative. So theoretically you can define this is the more acidic in nature. Roasting of sulfide. Next question same. Roasting of sulfide. Okay. Roasting of sulfide give the gas X as a product. This is colorless gas with cooking smell. Burnt sulfur causes great damages to the respiratory organs. Now the question is what here means. As a result, of the acid rain, its aqueous solution acidic acts as reducing agent and its acid has never been isolated. The gas X is what? Acts as reducing agent. Aqueous solution is acts as solution is acid, acts as reducing agent, and it's okay. Its acid has never been isolated. Okay, the gas X is what? So you can define the some particular results base, that is the sulfur dioxide. Roasting of sulfide give X is told here. Initially only given X, so it is sulfur related. X as a byproduct, colorless gas, cooking smell, burnt sulfur causes great damages to the respiratory, means this is sulfur dioxide or sulfur trioxide. Next is acid rains, its aqueous solution is acidic, acts as reducing agent. Okay, so CO2 can't be acts as reducing agent. SO3 can't be acts as reducing agent. In this case, H2S and SO2 acts as reducing agent. But here, what the aqueous solution is acidic, but H2S aqueous solution not that much acidic. Okay, and its acid has been never been isolated. Right, so sulfur dioxide is answer for this case. Okay, next is XeF2 is XeF2 is isolated with, is isostructural with. You can take the structure. XeF2 is linear structure. You know this one. XeF2 is linear structure, and ICl2 minus also linear structure. Why means I minus? I minus is similar to inert gas. So FC. So I minus also NH2 NP6 configuration. Xe is NH2 NP6. So these two will have the similar structures. Next is, which of the following does not give the oxygen, which of the following does not give oxygen on heating ZnClO3 twice? Okay, which of the following does not give? Okay, see here ammonium dichromate is right. See, based on the options it will give nitrogen gas, you know that. So ammonium dichromate according to equations. Next is, which of the following species contain 3 bond pairs and 1 lone pairs around central atom? 3 bond pairs and 1 lone pair. So what? Structural observation, PCl3. Next is, when Cl2 gas react with hot concentrated NaOH solution, the oxidation number of chlorine changes from where to where. So there is so many, okay, important thing is there. Hot concentrate is there, cold dilute also there. You can take both. Here question base you are going to observe Cl2 react with hot concentrated NaOH, then NaCl plus NaClO3 H2O will be formed. So in this case Cl oxidation state -1 and NaClO3 Cl oxidation state is +5. So change in oxidation states what? Cl2 -1, Cl2 +5. So that is only answer. If you want some other information, NaOH react with Cl2 then forms NaCl, NaOCl. Okay, in this case what happened? NaCl, NaOCl. So Cl oxidation state is going to +1 and Cl oxidation state is coming to -1. Right, 1 minute. Now next question is going to say a mixture of potassium chlorate, oxidizing agent and H2SO4 is heated. Okay, during the reaction which element undergoes maximum change in the oxidation number? So see, KClO3 oxalic acid H2SO4 changes to what here? K2SO4 Cl2 H2O. Now in this case Cl oxidation state is +5 to 0. So maximum oxidation state change is this only. +5 to 0 means how much here? Nearly 5 electrons gain. Remaining cases only the carbon +4 to CO2 it will change. So +3 to +4 it will change. 1 electron. Next is Next question is given as sulfur trioxide. Okay, sulfur trioxide